Welcome to today's webinar entitled Water Safety Risk Assessment for Construction, Developing and Implementing a Tool for Academic Campus Organizations. My name is Billy Zadig, Manager of Special Programs for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA website later this afternoon. Please visit our website at www.apa.org to register for upcoming events and to view archived webinars for continuing education credits found under the Continuous Learning tab. Professional Continuing Education and AIA-CLU certificates are being offered for today's program. If you are an AIA professional, please send an email to me at Billy, B-I-L-L-I-E, at apa.org, along with your AIA membership number if you have not done so in the past. Those who indicated they wanted a certificate at registration and meet the requirements will receive certificates later this afternoon. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time and we still have questions, responses will be sent directly to the person asking the question by our presenter. If you're just calling in, make sure to send me an email at billy@apa.org so I can send you a certificate if you would like one. The system will only recognize you if you log in. At this time, it's my pleasure to turn this over to Molly Scanlon. Molly, take it away.
Thanks, Billy. This is Caitlin Lydiard, Program Development Manager for Water Management for Construction at Phigenics. As Billy mentioned, Dr. Scanlon and I work together. And before we get into the presentation content here today, I just want to take a moment to read the company's bias disclosure statement. So Phigenics provides independent expert guidance for the development and implementation of water management programs to prevent building-associated injury and disease and to improve operational efficiency for facilities. We provide real-time monitoring solutions and cloud-based data management, as well as environmental testing for all waterborne pathogens and analytical services for water chemistry. Phigenics does not sell water treatment chemicals or disinfection products, nor do we have commercial affiliation or funding from suppliers or manufacturers of such products. I also want to take a moment to define several acronyms we will use throughout the presentation. First, ANSI-ASHRAE Standard 188 is the guidance document on risk management for reducing growth and spread of Legionella in building water distribution systems, or BWDS, as it will be referred to throughout the presentation. The next is the SRA, or Safety Risk Assessment, which will be the tool that Dr. Scanlon will review. And then finally, to differentiate between WMP and WMC. So WMP is a water management program traditionally implemented based on Standard 188 for an ongoing or operational occupied facility, whereas water management for construction occurs for significant maintenance, repair, replacement, demolition, renovation, or new construction, and occurs in that time frame between either during construction or once construction is completed prior to occupancy of the facility. Now it is my pleasure to introduce Dr. Molly Scanlon. She is an environmental and occupational health scientist, as well as a licensed and certified healthcare architect. Currently, she works as the Director of Standards, Compliance, and Research with a focus on construction activities at Phigenics. Notably, she's also an associate professor at the University of Arizona School of Public Health. As Dr. Scanlon presents, please continue to enter questions as you listen, and I will be back to queue questions for her at the end of her presentation.
Thank you, Caitlin, and thank you, APPA, for having us today. So here's our agenda. We're going to go through water management for construction. I'm going to discuss some background and research and frame it in standards, construction risk activities, the building water distribution system, how do we construct today, and what's the future process that we've been piloting. I'm talking about methods, and by methods, I'll talk specifically about risk matrices, a little bit on the history of them, what's been used in another building type, healthcare, and how we've been translating that to either community or non-healthcare settings, which includes an academic campus, and some examples from water capital improvement project or group that's talking about that. We're going to then take a look at what I'm calling a Water Management for Construction SRA Safety Risk Assessment Tool. It's a 3x3 decision matrix. That'll make more sense to you. We're going to look at it later. We're going to look at a pre-construction risk assessment tool, and then we're going to talk about implementation strategies. So let's go into our background. So for an academic campus in a community setting, it's kind of like a little city, and even if you're a local education, in the K through 12, or, depending on how large your campus is, these are like little cities because you're a good neighbor, you're an open space recreational area. And I think a lot of people think of, when they think of just the building and building it, they think of it as classrooms and things like that. But these are athletic venues. There could be dormitories, overnight stay, or hotels that are associated with the campus, food service, laboratories, facility infrastructure, and all of these have water designations to them. Also, many educational institutions are, they're leaders in green building design initiatives because of their community partnerships. And then you have even larger university organizations who have specialty curriculums. You might have agriculture or health and medical, high tech or manufacturing of some kind, or simulation curriculums that use water in different types of ways. So I want you to maybe think about that as you see today's presentation. Then what is the academic campus in the post-COVID world, and what does that mean for water? So this is a diagram that people show a lot about smart cities or smart campuses. And when I talk to people about water, we're kind of like, we're just a icon on the list. And that's about the end of it until there's a water crisis like Flint, Michigan or something else. But people don't often talk about water the same way they do air quality, for instance, as we've just experienced with the pandemic. So in environmental quality and sustainability, there's outdoor environmental quality, which is the overall, world in which we live in, but there's indoor environmental quality, IEQ, and that often focuses solely on air, but water is considered part of that, and the building water distribution system is part of that indoor environment. We also have infrastructure, surrounding all these buildings and in roads, and depending on how your campus is set up. And you all experienced as a part of this pandemic some type of work from home or mandatory, shelter in place shutdowns. You deal with seasonal shutdowns because of the campus, whether it's running, throughout the academic year and the semesters. You have aging systems in many cases. It could have lead and copper corrosion issues. And you're in a continually changing environment that's being improved. Similar to my long-term building type in healthcare, there's a lot of renovation and construction that goes on. So in terms of public health awareness in water and safety expectations, we could be talking about drinking water. We could be talking about water hygiene, which is often more bathing and hand washing beyond the drinking. You have recreational water. You have potentially health and medical treatment waters, depending on your campus. And you have occupational safety and health issues, OSHA issues, and then something in public health. So in healthcare, you may describe populations with immunocompromised, health because they already have an underlying health condition. In a public health setting or a community setting, we would call someone who may have compromised health or be susceptible a vulnerable population. So our specific topic today is about how we would use the water safety risk assessment in construction activities. And I always have people say, well, doesn't this happen after the building opens? And I said, well, maybe, but construction activities have been associated with disease cases and deaths, both in the US and abroad. And we need to put this on our prevention list. Excuse me. So key documents and training documents that you need to be familiar with, if not already. The first two are purchase documents. So ASHRAE has the ASHRAE standard 188. It was originally published in 2015. The current issue is in 2021. It's updated every 3 years. It's Legionellosis for risk management of building water systems. It has set the standard of care for how a water management program will be written, and others are following suit. There's a second document that's in public review but not formally published yet for all other water physical, chemical, and microbial hazards. It's called ASHRAE Standard 514. The P is in public review. It should be published in late 2022, maybe early 2023, so be on the lookout for that. If you want to understand water management in a larger context, the CDC Toolkit is available for free download. I call it Water Management 101 for all building types. You may need to be familiar with AWWA disinfecting procedures 651, 652. If you don't know anything about water management, there's an excellent training program that we created with the CDC with the University of Arizona in the College of Public Health. It's been up since 2018, I believe. It's a 3-hour module. There's 6 modules. You can take it in sections. It lasts about 3 hours, meaning you can take it in 1-hour increments or half hour, however you want. And you can get that free downloaded at the CDC website. So for the 1-minute version of what's in that program for training, for water management, the 7 steps of water management that are outlined in risk management documents are that you are to form an interdisciplinary team in your organization to deal with the water management program. You're to develop program goals. What are the boundaries of this water management program? Which buildings are in, which buildings are out? Think of it like a property line. Describe the water systems. These have to be done graphically and in words. So graphically, it's called a process flow diagram, PFD, not to be confused with the PDF we always talk about, but process flow diagram. And then it's also water use description. So there's a graphic and written description of this water system. You have to analyze the hazards of the building water distribution system, and you have to apply control. Flushing, disinfection, etc. What are you going to do to control the hazards is step 5. Once you have the system in place, the program in place, you have to verify monthly, quarterly, biannually, annually, whatever your team decides or what's appropriate for the occupants. You have to verify that the program that you have written is in place and that you are checking that it is being implemented as designed. Step 7 is to validate, is this program you wrote working? And that's by doing some form of a test. If the program is working, you shouldn't have disease cases emerging or deaths or injury from the water system. And so if your program's working as designed, then you check it in these periodic methods, and then you document it on a continual basis so that you have a defensible program. Within 188, there are sections about construction. So under the section 4.2, it says to the building owner, if you survey the building, which means if you opt into the standard of water management, so in a healthcare situation, it's mandatory for federal reimbursement. On an academic campus, that's optional. So if you're looking at this for various issues for prevention, you would opt in for your existing buildings. That's an ongoing water management program, WMP. But it also says in these paragraphs that you need to do this for any new building, renovation, addition, or modification to an existing building if you decide to opt in. And then if you do that, you're supposed to have a water management program up and operational prior to occupancy of the new building and before construction begins on renovation, addition, or modifications to these existing buildings. And so people say, whoa, okay, that's a lot for us. What does that exactly mean, and how will we do that? Well, in the back of the standard, it also has a section on design standards. If you are a design professional, I recommend you purchase this document from ASHRAE. I find a lot of designers are not familiar with these sections. I'm not going to go into designing the building today. But there's a section on commissioning, and it's commissioning the water quality. It suggests the design professional is going to hand a commissioning program over to the building owner. I haven't met a design professional that can do that for water quality. They do it for performance of the water system. Is it leaking, and does the hot water tank work, and is it meeting temperature? That's not what we're talking about in commissioning here. We're talking about what's in the pipe, not the pipe or the system itself. You have to do both, because if the system isn't working, the water quality will be poor. You have to understand disinfection standards, and then there is a small procedure written about when you would disinfect and flush prior to occupancy, and there's timing of 3 weeks before, whether you're going to occupy the building or not, and how the water management team would address that. But there's not really a how to do it. There's just a very limited amount of information at this point. This is the National Academy of Sciences, Engineering, and Medicine. This is a table from their 200-page manual. They recommend a water management program for all public buildings. Repeat, all public buildings. And so that's a recommendation, not a requirement by law. But they gathered a group of leading scientists and they published in 2020 their management of Legionella for building water systems. What I like about this chart is they do talk about operations as the main function, but they group it in conjunction with there should be a design process, there should be a commissioning process we're talking about today. Then you operate the building and then you do corrective action. So it's a system that you're working within for the water management program. In this document, they do talk about creating aspects of this program or understanding them in design, but here they talk about verifying the absence of Legionella in premise plumbing before occupancy. Again, this is a recommendation. No one's adopted that, or it's not a law per se. So what exactly are we talking about? So when I first got involved with this, when I was in the training grant with the CDC that I recommended earlier you might watch, is that I kept saying, well, these documents keep talking about designers and contractors and renovation. Exactly what are we talking about? Construction is a big term. A lot of things fall into that could be permitted, and no one could answer my questions. There had never been a gathering of the literature before of previous literature, and the gold standard to do that is called a systematic review, where you quantify that. So I set out on a journey since 2016 to do that, and we published our first article in 2020 about the different settings, community and healthcare settings. So everything, you have healthcare settings and everything else is considered a community setting as a building type, whether it's a school or whether it's a civil building or, the library, something like that. We looked at different construction types that we defined and could find in literature, and we looked at pathogens of interest. We were able to find 31 studies that had events dating from 1965 to 2016 that were connected to construction or associated with it. A lot of the literature was on Legionella, but we didn't find other pathogens of interest. We were able to find 894 disease cases associated with construction and 112 deaths and 9 construction activity risk factors, which I'll explain in a moment. Our recommendations from this study were that, we really need to incorporate construction as explained in these standards has to be more widespread in a water management program and its understanding. We need to start implementing these construction and commissioning practices. We need to raise public agency awareness. We need to do proper education and training, something we're doing today, thanks to APPA. And then we need to look at evidence-based policies for this water safety. We don't need to make it up. We can follow the literature and see how we're supposed to be doing. So here are the 9 risk factors. In healthcare, commissioning the building was the #1 problem and lack thereof. People just simply do not test the water other than for E. coli and coliforms before patients use it. You would think that might be done. All other systems are tested, electrical, et cetera. The water system is not tested for a pathogen. And so the building could open, have it, and it's the first thing that's used by the patients, and you end up having disease cases and deaths. This does happen in other building types, but the #1 in community settings was excavation and the connection of the water system. So excavation is because soil and sediment is dug up here and can invade the piping system. Soil and sediment act as a nutrient to a pathogen's growth. The system could be, another one is repressurization. The system, when it's repressurized, can loosen biofilms and send them downstream. You could also change the flow dynamics of the building after it's repressurized. In demolition, could be below ground in terms of utility tunnels and things, but a lot of people don't think it's above ground. There are many studies that show that above ground demolition of taking down buildings, road construction, or civil pathways creates plumes of dust that go up into the air and they settle into an adjacent or nearby cooling tower and they foul it. And the cooling tower is receiving a dosing of treatment for standard operations, not for a giant influx of soil and sediment into it that then begins to grow Legionella, and then drift occurs and it goes out and becomes a community outbreak. Construction equipment is associated. There are many pieces of construction equipment, tankers, power spray washers, sawing and cutting devices, where no one monitors, is this potable water, is this water safe? And they've actually gone into communities and sprayed communities or sprayed near buildings and intake valves where it gets into the setting of the building and causes disease cases. Water main breaks might be something you would commonly understand because of these other activities, but it was actually mentioned the least in the scientific literature, but it does happen. I think it's very familiar to people. Vibration has been associated with healthcare construction. It could be another building type, but it wasn't reported in the literature. But vibration occurs when you're doing pile driving, foundation setting, jackhammering, saw cutting of piping. You can loosen biofilms and have them go downstream to an unsuspecting department where you have a vulnerable population and creating disease cases or deaths. Many folks are designing for water efficiency, but they don't think of water safety. The program is not sustainable if it's not safe. So we have many designers that are trying to do water conservation or are applying laws for water conservation in their states, which is all good, but no one ever checks to see if these efficiency design standards for water are working in the building. They just open it or they design it for a vulnerable population that it shouldn't be, and a lot of the stuff has to be removed or then is associated with disease cases and deaths. And then underground utility connections, and it's obviously connected to many other factors here. If those are being changed out, either on your property or by the municipality that may be doing something adjacent to your property. So in these populations of risk, when we looked at the 894 cases, the majority, 70% of them, are in healthcare settings for obvious reasons with immunocompromised populations and underlying disease. But 30% of them were in community settings. It didn't differentiate, it just calls everybody a community resident, so it didn't differentiate them by building. But construction workers are also susceptible to this in both settings. If you do have a community outbreak, in this column, the mean number of disease cases with a construction activity are 36 to 37 disease cases could be associated with this outbreak. And so you can't use what we've just experienced at COVID. We're talking about hundreds of thousands and millions of people. In Legionella, an N of 1 is a disease case, an N of 2 is an outbreak. And an N of 2 can be over a 1-year period on that water system. So if you have a disease case on day 1, you have 365 days. If another one occurs, that's considered an outbreak. So it can be a long period of time. In healthcare settings, it's lower, but they have more deaths because of the population. So in terms of deaths, you may have 36 to 37 disease cases, of which 1 to 2 would be a death. And those are very legally challenging situations to be involved in. The event duration in a healthcare setting can be 17 to 18 months. Most of them in community settings are 1 to 2 months, and most in both settings can be handled in less than 6 months. So our pictogram at the top was for ongoing water management programs, and you may say, well, what's the process for construction? Well, we've been trying to apply the same process for construction. It's just that different people might be involved. Your team may need to be expanded to include contractors, maybe a construction manager or an owner's representative, either within your organization or somebody you hire. Maybe you're going to have a safety risk assessment manager. Maybe that's the person on the team. Maybe you have somebody associated with construction. Some people have industrial hygienists on their campus that would be qualified for these types of discussions. The process is the same, but what you do in these processes, because the building might be empty, might be different. I'll explain that in a little bit. So let's talk about historically how a building is put together, and I'll talk from new construction for a second. So you have this civil package, underground water is assembled and underground piping and brought to the site. And then it's usually tested for E. coli and coliform only. Some people will do a general bacteria test, but it's not mandatory. And they'll just valve it off, cap it, park it, whatever you want to call it, and deactivate it. And they'll just sit there until the building is going to be built. That's a dead end. And so the water continues to degrade and has high water age. The building gets built, shell and core. And at some point, the contractor, for their convenience, says that they're going to activate the water system, not because the owner needs to use it, it's because they're going to use it for either contractor bathrooms or for materials assembly. I call it adhesive and muds, to mix something that needs to be used in the building. So they just fill up the water system as they complete it, and they move on to their tenant improvements. No one manages the water. They just draw a small, tiny amount of water off of this system, but they fill it to its capacity, and they only use this tiny amount. Meanwhile, all of the other water is in a highly aged state. The specifications should be, but may or may not call for disinfection procedures, and the contractor, often the specifications don't have a date associated with it. So they just go check. They just do it whenever they feel the plumbing person and contractor or whoever they're going to have do it comes out, and it's just a checkbox for them. It has nothing to do with a schedule and time. Meanwhile, the standard is calling for it 3 weeks before beneficial occupancy. So then we move toward, they hand it off. It's a successful, let's say, building project. There's a punch list where it's substantial completion. So if you're not familiar with this term, it's substantial completion. They hand it over to the building owner. The warranty is starting in some period. And the building owner starts to move in, and they're going to head toward what I call first business day of operations. And they're using all this aged water in small quantities. And then when the building opens, all that bacteria-filled water is the first water that's used unless the building's been completely flushed and properly disinfected. And soon, if it sits, it's just as if nothing happened at all. Is that the water you want used on the first day of when the building's open? Doesn't sound good. And then if they want a water management program, they start it over here somewhere. Seems backwards. So the process that we've been experimenting with and doing with building owners is, can we make this situation better? And the answer is yes. So you still might build the civil package. You're still going to, build the shell and core and start your tenant improvements. But can you have a discussion with the contractor about delaying that potable water activation? We've had many contractors say, hey, why don't we bring a temporary water source to the site and temporary piping, and we won't use your piping until later. We'll find some way around this. Maybe we'll use air pressurization to test the water fixtures instead of having to activate all the water too soon. I'm not a plumbing professional or engineer, but you can have that discussion, and we have had some very creative thinking with the contractors of how we could have a described day, a specific day for water activation of the potable system, and then manage and start the water management program from this date. Not wait until the accident happens. Start it from this date and begin to use the water, disinfect within the 3 weeks as described in the standard, and maybe you're testing the water in here for various things depending on your organization and the vulnerable populations. Simulate occupancy through a flushing and disinfection protocol, and have healthy water so that the water that you use that comes out at the first day of business occupancy is what you want to be exposed to, not foul water that is dangerous. In a renovation, that would be different. You already have an active water system, so how would you isolate the renovation area so that the water can flow around you, but then you take the system offline? Maybe you can't do that. Maybe you have to flush fixtures within the zone of renovation. How are these construction risk factors impacting this project? Will that impact the water main at the point of entry, or is it at a central plant? When we've started having conversations about this, it's shocking to find out how much water is being manipulated in a building in construction, and no one's ever been checking this before. And this is where these disease cases and deaths have occurred. So from an academic standpoint, academic campus standpoint, education standpoint, and from the NASEM, if every public building has a water management program, how would we go about having a project-specific water management for construction program and commissioning? That might be daunting. And how would we do that? And your teams could, effectively narrow this down so that you could have quality water from beneficial occupancy, when you start up, rather than what I described before. So let's take a look at some methods we've been analyzing. So many of you have probably seen a table like this. This is a risk matrix. It's from Occupational Health and Safety. It's an industry culture thing. I'd be surprised if on your campus you're not using some version of this for something. This is very common from the 1970s in aviation and transportation, or in the financial sector. And they look at severity on a scale from negligible to severe. This is a 5x5 table. Why? There's 5 columns and there's 5 likelihoods. And then what's the likelihood of it happening? What's the risk? What's the likelihood? The risk is severity times likelihood. So is this very unlikely, unlikely, possible, likely, very likely? And then you have a precautionary thing that you're going to start with by having low, medium, high, and highest. So these are commonly used. So recently, in 2022, I saw that someone for capital improvement for municipal water was publishing Cott and Payne in OpFlow from AWWA, published severity of public health impact in minimal, moderate, and severe of what they're dealing with these capital improvement projects, and then what's the likelihood of that happening to the population. And then they were talking about how you would define that. Also, the area that I'm from with construction with healthcare, or have had a long suit in that, I'll call it, before moving into public health, there was always a program for using a risk matrix for infection control risk assessment, sometimes called an ICRA, I-C-R-A, instead of the S that we're putting here for you for safety. They have infection preventionists that looked at airborne pathogens, and they have been using a risk matrix. This is a 4x4 table for non-invasive, modest, medium, and large construction projects. And then they would look at their risk groups, and they rank the risk groups by vulnerability based on immunocompromised populations. And then they have something they call class of precautions. How could we use that? So recently, I, myself, and some other investigators down here, this is in the open domain. We'll show you later how to access this. This is a 4x4 table for construction for water, but it's for a healthcare situation. And we're going to adapt this for the SRA we're going to talk about. So this, in the building water distribution system, they classify their project. How much work are they going to do on the building water distribution? Are they going to do minimal, small, moderate, or large? And what's the water age that's associated with that construction? Is the system going to be shut down for less than 24 hours, less than 7 days, less than 30 days, or greater than 30 days? And these stratification points are based on literature. What's the building occupancy risk group we're trying to protect? And then what's our water class of precautions? So how would we go about using that? So we have many clients that say to us, well, we want to check the box of being, on water management and using this process. But hey, we really like this risk assessment process. How could we do both of these with one process? And that's what we've been looking at with tools and experimenting with the commissioning process. So I'm going to show you some. These are preliminary results. These are not published, but this is the process that we're showing. So what we're suggesting for non-healthcare, for community type buildings that are in the public domain, maybe a 3x3 matrix would be simpler for this. And we don't have the 24-hour because we're not dealing with patients, but for vulnerable populations, we would look at something where water stagnation is in less than 7 days. So the system is shut down in less than 7 days with flushing, less than 30 days, or greater than 30 days. And then how would you look at low, medium, and high risk, and how would you make this chart work in that capacity? And then what would your class of precautions be? So here's the tool. I'm going to show you this in a bigger format. I'm going to go out of my slides in a second, but just a 3-page tool. There's a disclaimer. You can never eliminate risk. Risk is never zero, even if it's 0.000001. There's always some risk, and every building water distribution system is different. So there's always going to be some risk. So there's a disclaimer up here in using these tools. Here's the matrix. And then there's a tool on project categories. There's an explanation of the type of A, B, and C. There's a risk group, which I'm going to show you the one for academic. And then there's these class of precautions. They're called water mitigation risk levels here. And there's 3 of them, and we'll show you those. So I'm going to do an escape out. I hope this works because, whoops, that's our picker tool. Let me go out. And Caitlin, can you tell me that you can see the tool?
Yes, I can.
Okay, all right, so everybody's with us. So here's the actual 3-page tool. Here's the disclaimer at the top. Here's the risk matrix. So you're going to use this by classifying your construction first. So this just helps your team narrow down where you are on this placemat. It's not to eliminate all your thinking. You have to use your good senses about what you're doing with this construction project and exceptions to the rule, but this helps you narrow down where to start. Then here's your risk group over here. So in a category A, it's kind of inspection, maintenance, and repair. These would be like for like or small area of construction. It would be localized to a room, floor, or department. You might be working in the wall cavities and above ceilings. This is very different for healthcare in that they have a 24-hour or less, but this for the 7-day or less, you could work in a small area and think of it as who is the water system going to, which my construction is going to impact who. And if it's a small area, then you're protecting that group of people. And that's how you determine that. Under B, you might be working in a larger area, or you may be taking out a major part of the system, a boiler, a heater, a water main is being manipulated. It might be handled in less than 7 days because you're going to handle more people or expose more people. And you may have up to 30 days then to look at category B. And then category C is sort of everything else. 30 days and bigger, all the big construction projects, you'll have to have some type of unique water management program. The most important thing you're going to do in the tool is your group is going to classify low, medium, and high risk. So let's walk through this for an academic institution. This is up to your team to determine. In healthcare, they do this based, again, on immunocompromised patients. In your case, you're going to be looking at vulnerable populations and the water fixture type. How dangerous is what that water fixture is? What type of aerosols are coming out of that? So low might be admin areas, classrooms, conference rooms, a dry laboratory that really doesn't have water, lobbies, or office areas. Medium might be cafeterias, nourishment areas where you have ice machines, they're under regular maintenance and things, but you may have wet laboratories. You may determine some of these to be low or high, but you may start off with having a medium category. And then there could be all these high categories. They're kind of the exceptions of where you've got aerosols. Do you have cooling tower drift? Do you have cooling towers? And are you going to have cooling tower drift? Do you have athletic facilities, whirlpools, spas? These are considered recreational waters, but you have showering. And these are not just for students. There's faculty and coaches who may be in the vulnerable population category above 50, age of 50. Do you have child venues or pediatric venues where do you have faculty child care centers or anything like that? Do you have overnight guest staying, a hotel or lodging that's on your campus? Do you have these special curriculum and high pressure washing for agriculture, high-tech mining, or at the University of Arizona, we have a telescopic mirror lab that uses high-pressure water. Do you have open campus public venues where you have decorative water features or shallow pools that need to be maintenance? They should be part of your water management program. And what are you doing when they're under construction or maintenance? Simulation and practice centers. Some people have medical simulation centers or nursing simulation centers. They bring in practice patients. I use that word in quotes. They are simulated patients, but they are live as opposed to the simulated dummy. You have seasonal venues, athletic stadiums that are shut down for part of the year, field houses and arenas that are not operating all the time and have stagnant water. You have dormitories with showering. You may have, well, I don't know what all campuses have now. You may have single occupancy showers. You may have group showering. You may have, communal shower areas within these dormitories that have to be considered. Do you have student health and well-being that maybe it's not overnight stay for inpatient like a hospital, but should you be taking any consideration for infirmaries, outpatient clinics, or disability resources? Your organization needs to come up with this chart. This is just an exemplar. Then the actual risk assessment categories. Let's look at the bottom here. Sorry, on page 2 in the bottom, we start with, well, what are the actual things you would do? This is kind of a checklist. You would say, well, if we have a category 1, maybe we're going to put up a little barrier, or we're going to close the door so people aren't exposed to the aerosol. We're going to put up a plastic barrier or something to keep this water contained while we're under construction. Maybe we're going to do some baseline measuring. What's the temperature of the water? What's my residual oxidant? Do a before you do the construction activity and find out, and then put it back the way you found it or better. Perform your repair or replacement, and then do post testing of residual oxidant and temperature. Is the building defensible? Is the space defensible? Should be the same or better. And maybe your chart wants to include what your water ranges you're looking for cold and hot. There's an exemplar here. Maybe you want to put the range of residual oxidant you're looking for. This is the typical for chlorine. It might be 0.5 for a chlorinated system. On the low end, are you looking for odor, discolored water, flecks, or floating debris that may have occurred so that you know what's happening? And then how do you close up the construction project? That's under section 1. Under section 2, because the project might be bigger, you might need to calculate water volumes. How are you going to flush? How many minutes a day or how many days a week? A lot of times when you're working on these new projects, we have recommendations of 2 days a week spread out. 5 minutes, hot, 5 minutes cold. But anyway, that's up to your organization. Are these in occupied areas? Are these in unoccupied areas of the construction zone only? Will you need to do residual oxygen temperature readings? So there's a whole choice of controls. Hyperchlorination. Do you need filtration temporarily? Do you want to do auto flushing fixtures? These are to stimulate ideas about how you would apply controls for construction and tell a contractor what you want done. At the end of that process, do you want to do any water testing, meaning laboratory analytical testing for metals or water quality of bacteria or microbials? And then section 3 is that writing a semi-custom program, and how would you go about that? So the second tool that we provide in our paper is about a safety risk assessment. And here's all those risk factors I talked about, divided into site risk factors. Have your contractor, when they're explaining their project to you, yes, we're doing excavation, or no, we're not. Or what's the length of the unoccupied space? So what's going on with vibration activity? So all those things are listed out here, both for the site, and then there's a checklist for the building risk factors. So those are intended to be helpful tools that you'll want to probably download. Okay, so let's go back to our presentation mode and get back into our slides. We can finish up here. So this is the 3-page tool for safety risk assessment. This is the PICRA. That's what it's called in healthcare too. It's pre-construction risk assessment. It's the same risk assessment. It doesn't matter what building it is. So remember, there's the site factors, there's the building factors. So then you say to yourself, okay, I've got all my tools. I'm ready to take this. What am I going to do? How am I going to implement this? So here's what we found out. And this is what I would do if I was in your shoes. So you need to really evaluate what regulatory guidance applies to you and why are you opting into the standard? Is there any regulatory reason why? Is this voluntary? Are you trying to be a best in practice organization? Have you had an incident? Are you concerned after this COVID situation of how your building shut down, et cetera, et cetera? Make your own evaluation of that. You don't have to believe me. Read the scientific literature yourself. Download a couple of these articles and take a read. Look at the tools and decide if this makes sense to you. If it makes sense to you, maybe you want to consider that. Do you have a water management program and team already? If you don't, maybe you want to consider, incorporating one. If you do have one, and it's for ongoing operations, maybe you want to expand that a little bit and start talking to your planning, design, and construction team, and how are they going to be incorporated in this? Unfortunately, I've found that a lot of those these disciplines have been just left out of the conversation. It's not that they don't want to participate. For some reason, these standards have been written without a lot of their knowledge. It's been mostly by chemists and microbiologists. That's not a criticism, it's just how it's been evolved. And so we need to spread the word. Review your existing safety risk assessment policies for construction. Do you want to include water? Some organizations already include airborne pathogens for aspergillus for construction, as I demonstrated that is true for healthcare, but I also see that in academic institutions. Maybe you want to expand that now to include water and what should happen with that. And you're going to need to prepare your group for training and education. There's just no doubt about that. I run into that all the time. If you are a larger organization, I think you're going to want to consider changing your specifications. So your procurement documents or bidding documents that you put out. So if you're a large real estate holder, large university campus, and you're issuing a lot of projects, or if you're a smaller organization, you may want to talk to your architectural and engineering professional and say, our general requirements, we really want to incorporate waterborne pathogens and how people are working in our settings. And so we're going to change some of our general requirement descriptions. You may want to take these PICRA and SRA tools and directly insert them. Again, ours are on water here today, but I've seen other ones on air. You may want to make a complementary add to that or consider that. You may want to consider we're in the process of trying to write specifications, and those might be some future tools we're going to put out, but some people are talking about writing a water management under the plumbing division and the commissioning area. Commissioning agents are not familiar with this again. this is not intended as a criticism. Everyone is checking the pipe and the water heater and that the water circulates. They are not checking the quality of what is coming out of the pipe. You need to remember, this isn't electricity, folks. Electricity is the same the day you start it to the 10th year you use it out of the socket. Water is organic. It degrades from the day it leaves the municipality that treated it. And it is an aging organic material in a pipe. It is not a standardized thing like electricity. That is very confusing to people, and you need to remember the difference. So what have we been finding out by commissioning and mishaps, and what could help you? If you're just wanting to get started with some simple things, if you have a project schedule that includes these water activation dates or what's going to happen, you're going to be 90% of the way to having a better project. That's what I found. It's just opening the conversation and talking to people about it on your project. So get a schedule and get those dates on about how the water is going to be activated. We find that really the systems are highly dormant. They've been sitting there for months or years, and they lead to high bacteria and waterborne pathogens. People don't know because they don't test it. You don't want to be afraid to test it and then have an accident. And some people want to wait until there's a disease case and a death. That's your organization's choice, but that's an expensive, defensible situation to be in. People need to learn to check the temperature of the system, not just at the water heater, all the way out through the mixing valves, water heaters and pumps. We find that these either haven't been sized correctly, people haven't checked them, or they're defective equipment that came onto the site. Or unfortunately, we've had some contractors have substituted products or components of these systems, and they weren't checked in the process of construction, and the building owner didn't know it, and their system can't even function. If you check these systems either before the construction period's up or under the warranty, you can get the system fixed and not have these find out outside of the warranty period. Disinfectant residual. Did anyone plan for this during the construction project or not? Did you prematurely install nourishment, ice machines, other water reservoir equipment that you shouldn't have, and do that closer to opening day? Do you have sediment and soil invasion either on your site from civil activities, which is very common in these community settings, or do you have your municipality doing off-site construction? Are you planning to occupy the building right away? Some people build and occupy parts of buildings and they don't occupy the building completely, and you maybe have to valve off, or maybe you shouldn't fill parts of the building rather than having the water sit there. And then there's a tremendous lack of awareness of training and terminology. The water management terminology has been set. These efforts that I've been doing in our organization, we're trying to translate existing water management practices into tools that will easily integrate into construction to kind of jumpstart this and make it easier for the design and construction professional to participate on these teams with you. If you need some resources and links, these are all free, some from the CDC, the couple of papers I've mentioned, the National Academies document I mentioned. If you don't want to you can bookmark on our webpage. We have a standards and guidance from everything from EPA and water to the CDC. So we have hundreds of connections. If you're a water geek and want to have that, you can get that on our main website. So this ends the formal AIA continuing education portion, and we're going to move into the Q&A. So Caitlin, take it away from me.
Sure. So we have a number of questions in the queue here. So
start with something easy.
Say that again.
Start with something easy. I'm just teasing you.
Yeah, definitely. No. So one of the things, one of the questions here, looking at these tools and walking through this process, can you outline a little bit about more specifics with team members who would be involved in this process?
Okay, let's go up to one of the water management pieces here. So if you don't have a water management team, so the first thing you need to do is set a team. That team is multidisciplinary, interdisciplinary. It typically is going to involve who is in charge of facility operations and the plumbing distribution system. There's probably an in-house engineer, maybe you have plumbing technicians, etc. Some people have administration people. Maybe you have a sustainability group that should be part of this team, but definitely someone from safety and risk. So this may be an industrial hygienist or someone from that department should be on that team. And that's for ongoing operations. Then you want to complement that team with who you want for construction. Again, in my history with healthcare, these are very different people, and they are contracted out. So depending on the scale of your organization, some of these people may be all internal, some of these may be contracted professionals to your organization. And you can include the design professional as well, but they are usually, delivering the design and specs, so that person could be too.
All right, so next question here. Are there any plans for ASHRAE to incorporate testing procedures into any commissioning guidelines?
Testing is optional at this point in terms of the pathogens of interest. Now, so testing is not mandatory. It's good practice to test. And there's a couple of guidelines coming out on commissioning and recommissioning for, and that varies by state, I should say. So you may be in a state where something is going to become mandatory to test. For instance, in New York, cooling towers have to be tested or something. So what ASHRAE, the standard is about, isn't the testing, it's about the process. It's about, and then you have to fill that in by determining that. So the good news is your team's in control of that. Now, AWWA and IAPMO are in public review of a document of recommissioning, and they are looking at best standards for what you might consider for a sampling plan for something like that. And I'm also on an IAPMO committee about construction and how to deal with a sampling plan. So really, you need to go back and look at your vulnerable populations and what you want to test for and how you want to test. The CDC has outbreak investigation sampling plans, but those are a little different. So I don't know if that's a good explanation, but it's in the control of your team to determine what that is. And that's a good thing at this point. So you want to be proactive, and a consultant can help you determine some of those things. If you want to look at consultancy selection, the CDC does have under their Legionella checklist, there's 7 criteria they have for how to select consultants to deal with this type of thing.
All right, next question, kind of a similar idea here, but is there any plan for developing training and commissioning requirements and practices for commissioning service providers or building operators?
Yeah, I think various folks are looking at it. Again, people are trying to get the standards out first and these tools. My one recommendation is, again, you can go to the CDC website, just learn about water management to begin with. Whether you're applying it during construction and commissioning or not, you need to understand these general processes and terms. ASSE International has it's called 12,000, it's 12080. They have a 3-year certification course. It includes a module on construction. It's just an overview. It uses some of the research that I've presented here. And so some people are getting certified in that. I think there's going to be a lot more training and things to come, but we've got to get these tools and standards up. So that's what we're training to. And so I think you're going to see a burgeoning of that over the next 2 years. And so it's things like this where you need to get familiar first. So if at all possible, go on the CDC's website and take the free online Legionella water management program training, and just take it a module at a time and start to understand these terms. Applying it then to construction is not that much more difficult.
All right, next question here. So in the case of a facility, university type facility with traditional university components and academic medical center components, how would that type of facility determine which tool to use?
Okay, if you're an academic medical center and you're receiving patients that have federal reimbursement, I highly recommend that you visit this tool, the WMC-ICRA. It's already published and in the public domain. I have colleagues at the CDC, we have colleagues at the Joint Commission who are supposedly reviewing this paper and looking at how it might apply. So no one's adopted it into any type of a standard yet. But this, to me, we've had a lot of people look at it, it's been peer reviewed, and it's being well received. So I would take a look at this a document first. It's in infectious, it's in infectious disease reports. If you're the academic institution and usually that's a separate business on their academic campus, right? You may have overlap with academic medicine, but the hospital is usually operating as a separate business. So you want to use the ICRA. If you're talking about the academic campus for the community and non-healthcare settings, then you want to look at this SRA decision matrix and more of the 3x3 that I walked through in detail. This paper is not in publication yet. We're trying to get into pre-publication by Labor Day, so that we're kind of doing this presentation ahead of time. So you're seeing some of these tools for the first time. So that's how I would differentiate them. Just if you want to, let me click out of the presentation. If you want to see these tools, go to Google Scholar, search on water management for construction like I'm doing on the screen, and both papers are going to come up. The original paper on water management for construction for evidence of risk characterization on the 9 risk factors, that's the first paper in 2020, and the second paper is going to come up. So just go to Google Scholar, type in water management for construction, and you'll find out those are the only 2 papers, unless it's stormwater, for building water system that have ever been published on the collective knowledge that I know about. So hopefully that's helpful to folks.
All right, and then the final one here, it's not a question, but I do want to see, Molly, if you have any comments about it. So this person says AWWA standards C651 and 652 apply to water utility main disinfection practices and not the building distribution system.
That's correct.
And
that
then
is correct.
They also made a comment that that AWWA's premise plumbing committee is completing a new guidance document that applies specifically to buildings to hopefully be completed later this year.
That's correct. So that's a knowledgeable person there. So let me answer it this way. The standard refers to the AWWA standard. So we can't currently change the way the ASHRAE 188 responds to this. So the AWWA and the plumbing codes have recognized that this is probably not the correct reference, but it is the reference that's in the standard. So if the standard's being adopted and applied, I'm not at liberty to change some standard on a whim. But what that person is saying is that it has now been recognized that we should not be taking civil utility standards and applying them to the building water system. However, every plumbing code and every standard currently does that. So that group that's looking into it needs to quickly come up with what their recommendation is so that these standards can update themselves. So that's a bit of a conundrum there between historical references and what will be new references. So, I'm not a lawyer, I'm not, but I'm not allowed to just sit here and tell you to ignore what's already printed in a published standard that's been adopted into law. So that's a good point, but it's, we have to be careful here. So that's the only thing, the way these are written. I think as a caution, what they're trying to get at is that C651 tells you to disinfect the water system at high levels, 50 ppm in 24 hours or 200 ppm in 3 hours. And they're thinking of changing that association of chlorine disinfection to lower levels for premise plumbing versus what would be done in civil piping. That's what they're trying to get at.
Perfect. All right. It looks like that concludes the Q&A portion then here.
Okay. Well, Thank you to APPA and to our audience today. If you have any follow-up questions, you can reach us. We put our contact information at the back, so you can go to info@Phigenics and leave a question or comment, or visit us on our Phi Construction website, and we'll be happy to get back to you. So thanks a lot, everyone.
Thank you, Molly and Caitlin, for doing this in a very informative webinar today for us. And to our attendees, as always, thank you for taking time out of your busy schedule to be with us. So until next time, be safe, stay healthy, and be kind to one another. Thank you so much. Bye-bye now.